I believe that's something that industry is really missing the boat on. I mean, I've been involved in a number of projects in industry that, take a long time to get started, to run smoothly when they're handed over from, say, the engineering and construction to operations. A lot of times the construction isn't even finished. The contractor by that point in time has made, really blotted his copybook, so to speak, and they're pretty much thrown off site, and it's over to maintenance. Hey guys, make it work. Here now you got people that don't know anything about those new systems taking it over and learning as they go. They might have commissioning spares, pretty much all of which were designed for the PM programs that the manufacturers recommended. And if you've ever done any RCM work, you'll know that those are usually not the right things to do.
Hello, everyone. This is Jesse Zadanek from Dynaway with Dynaway Dialogues. Thank you for joining and welcome to another session. I want to welcome our guest today. I'm excited to have, I want to get this right. I'm really excited to have James here, James Reyes-Picknell. Now, James, tell us a little bit about your background. I understand that you've been in maintenance and reliability and asset management for over 43 years. You've had a career working in really on both sides of the fence in kind of hands-on maintenance and in consulting and management, and worked for some big powerhouse companies as well as starting your own firms. First of all, welcome. It's a pleasure to have you.
Well, it's a pleasure to be here, Jesse.
Yeah,
Appreciate that. Yes.
yeah. And it sounds like you've really made a mark on the maintenance and reliability uh, field, and I'd love to hear more about kind of how you got started and how your career evolved.
All right, great. And I congratulate you on getting my pronunciation of my last name better than I do. Yeah, the Reyes part is Spanish, and I can't roll an R at all, so
I mean, either.
it's interesting. But anyway, yeah, I got started kind of accidentally in the maintenance field. I came from a pretty modest background, got into university taking mechanical engineering, and wasn't really sure how I was going to pay for second year. And along came an opportunity with the military here in Canada, the regular officer training program, where they actually cover your university costs and put you through university. And needless to say, I took it. Gave me a good summer job while I was in university, and then a guaranteed career when I left, which was kind of nice. And I enjoyed the military. I had previously been in the Reserve Army here in Canada, but I ended up in the Navy after considering different options. Navy being the one that I thought had the most application of any engineering principles that I'd get to use, and probably the least amount of administrative work, which didn't interest me in the slightest. So that's where I got started.
Hmm.
I moved on from there to Esso Chemicals, or Exxon Chemicals as it's known there in the US. When I finished in the Navy, the military had wanted to move me from a shipboard posting. I really enjoyed my time at sea. And they wanted to move me from there to the defense headquarters, which is in Ottawa, and that's basically a bureaucratic jungle up there. And I had, again, no interest in that at all. So I said, look, I'm out of here, and I went
Hmm.
and joined Esso Chemicals. So that was kind of where I got started in it. In the Navy, it was very hands-on, operations and maintenance combined. You operate the systems, and if they don't work, well, your crew fixes it. And in the middle of the ocean, there's nobody to come and help, so it's you and
Right.
your crew, and that's it. So you do learn to keep things running really well. You learn how to take care of them, and of course, you get pretty creative when things go wrong and you don't have what you need. Um, the Exxon Chemical role was a little different because it was, needless to say, on land. Instead of one ship, I had 7 petrochemical plants. Focus was exclusively in maintenance and reliability, supporting the maintenance working crews, mechanical and electrical, mostly instrumentation. Um, and providing sort of engineering insight, if you will, and some design work when things weren't working well for us, and we needed to modify them to work. So it was quite interesting. There's always a lot of challenge in it, and that's really what I like about maintenance. That there's never a dull moment, and the challenges just keep coming one after another after another. So that's kind of how I got started. Um, when the Navy moved me out, I kind of decided, look, no more bureaucracy. ESO, I didn't have to worry about bureaucracy at all, but I still had this passion in me for ships and military stuff. So the Canadian government at the time was just starting a shipbuilding project to replace the ships that I had actually sailed in when I was in the Navy. And so this project, the Canadian Patrol Frigate project, came along, and they were looking for people to support, with maintenance background and reliability background. And of course, I now had that.
Yeah.
So I took that with me to the project, and learned a little bit more about some formal reliability methods like reliability-centered maintenance. I hadn't used that before. Um, in timeline wise, you have to think computers were still pretty new.
Right. Yeah.
Desktop PCs were just brand spanking new. We were using like an XT was a big deal back then. And there's probably a lot of you listeners here who don't even know what those are.
Right.
But we were introducing computerization and computerized tools to help in some of the work we were doing in developing both the maintenance and reliability program using reliability-centered maintenance, and then the maintenance plans that came after that. So we were developing those. The thing that I learned a lot from both the Navy and ESO was listen to your people. And in the ships it was the chiefs and petty officers. In ESO it was the millwrights, the supervisors, the superintendents, and really pay attention because they know what's going on in the field, and that stuck with me. When we're on the shipbuilding project, of course, I had a group of people which was a combination of ex-Navy personnel, mostly chiefs and petty officers, and then some young engineers right out of university. And it was a really interesting combination, and we got to leverage the two. And one thing that I started doing that they hadn't been doing up to that point was to put the two together in teams, so that you've got this experienced person with this person who's got that mathematical, more academic problem solving approach, and that proved to be very, very powerful, very powerful. So that's really how I got started in the career, and eventually that project came to an end. I'd moved on in that, got into aircraft and helicopters specifically, and then landing systems, and doing the same thing, and then into consulting.
Right.
Coopers and Lybrand was the consulting firm at the time, one of the big five, I think that was in those days, and they were looking for somebody to join their maintenance management practice, and the leader of that was a guy named John Campbell, who I hadn't met at that point, and he was just in the process of publishing the first edition of the book Uptime, which he authored. And they were looking for somebody. I fit the bill. John, at the time I was living in Halifax, Nova Scotia, he came down, interviewed me, and we really hit it off quite well. And before I knew it, I was moving to Toronto to join his practice. um, so that's kind of how I got into it. And of course, the maintenance and reliability expertise has just grown over the years,
Right.
with practice. Largely, and combining that knowledge that you get from listening to other people with putting it into practice. And I think putting it into practice is what really matters, because you do make a lot of mistakes, and I've certainly
Yeah.
made my fair share, and you learn from those. And that just builds that level of what I call knowing that you carry with you. Now, after as many years as I've been at it, there's quite a pile of it, and
Yeah.
lots to share, shall we say.
Yeah. Wow, that's a fascinating journey. So many stops and so many great projects that you were on. I guess now I want to ask about you were at some big consulting firms, and now for I think the last 20 years or so you've had your own practice, and with tell us a little bit about your current your current practice, consulting practice. What do you find most rewarding about running your own consulting practice, and how have your clients benefited from this background that you've had?
Hmm. Well, I think a big, I mean, I find rewarding the fact that there's always a new challenge.
Mm-hmm.
I'm a lifelong learner. I like to share what I know. I teach, and I've got a pretty good memory. So when I'm confronted with problems, I can kind of draw on all that background and use it to help people solve what are today's problems for them. So I find that very rewarding. I mean, I got into that, on my own because of transitions that were occurring, right? Cooper's merged with Price Waterhouse.
Right.
We went from what we used to joke about it, that the Price Waterhouse people wore starched underwear and the Cooper's people wore none. So it was a bit of a culture clash, but it worked. It was right
Yeah.
around Y2K, and it kind of worked
Yeah.
reasonably well. But not long after that, you had the Enron and WorldCom incidents, and that led to Sarbanes-Oxley. So the big firms were now looking to basically shed their consulting wings. And in PwC at the time, we went to IBM. And
Mm-hmm.
so late 2002, I got into IBM, and it was a big bureaucratic organization, which, as you might gather, is not my forte. So
Mm-hmm.
I really didn't feel comfortable there. Computerization was growing, and needless to say, in
Mm-hmm.
a company like IBM, it was a big deal.
Yeah.
Rules and procedures were the way you did things. You didn't use what I would call common sense some of the time, and you actually had to reverse your common sense to use the computers in a few cases. So I just didn't. It didn't fit. And I
Yeah.
said, look, it's time to get out of here. It was an interesting juncture in my career and my life. I'd got quite a bit of experience. I knew it was useful. At that time, I knew I was very good in consulting. I'd moved up through the ranks. Um, it was time to sort of reassess what did I really like in life, and
Yeah.
big bureaucratic organizations weren't the answer. The thing I enjoyed the most up to that point was my earlier years in Cooper's,
Mm-hmm.
which was quite sort of freewheeling entrepreneurial
Mm-hmm.
spirit. And I thought, well, the only way I'm going to get to duplicate that is to go back into consulting on my own or in another small firm.
Mm-hmm.
And there was an opportunity with a small firm in Australia at the time, actually. I'd also, my first marriage had ended, and I was now just getting started with the lady who is now my wife. And, and the idea of moving to Australia really wasn't that appealing at the time.
Right.
So started my own firm, and I've been at it ever since. And I find that, for the clients, you've got this experience that's built up. I've stayed focused in maintenance and reliability.
Mm-hmm.
That's really all I've been doing for the last 20 years, but I've been doing it with a lot of companies, and
Mm-hmm.
I've seen an awful lot of ways to get things wrong, and I've seen a lot of things that have worked, and I've developed some of my own thoughts on why things work where they do and why they don't where they
Yeah.
don't, and that's really helped a lot because I can use that insight to help the clients make improvements. Um, and some of my clients are actually bigger firms.
Yeah.
They bring
Wow.
me in, like they want this, they want the that subject matter expertise that they
Sure.
don't have with the recent grads, the MBAs. They don't teach this stuff in school. So
Yeah.
and
Exactly.
I've got the piled higher and deeper degree in hard knocks, if
Yeah.
you will.
Exactly. That's the real education, right?
It really is. Yeah,
Yeah.
yeah.
Let me ask you. So you've been working mostly in maintenance and reliability for 20 years, and I'm sure you've seen computerized maintenance techniques and software evolve over that period of time.
Oh yeah.
You mentioned sometimes in the early days you kind of had to do it backwards to get it to reverse engineer it into something that worked for the software, but not necessarily for the company. How have you seen that evolve over time? And is software at a point, and maybe what do you see in the future as the next evolution? So where are we at currently? Are we able to really take advantage of um, uh, computerized maintenance solutions to their full effect, or is there still a lot of meat on the bone out there?
Lots of meat. My remark earlier about the computers was not actually related to maintenance systems. It was around business systems, and honestly, they're still just as messed up as they were back then. So, what I see in the maintenance world, though, and I've gone from, like, in the Navy, it was all on paper.
Yeah.
At Esso Chemicals, it was a blend of paper systems
Hmm.
with some very rudimentary homegrown computer system, which basically just managed work orders for us. If we wanted to do any fancy calculations, it all went offline.
Hmm.
I think I was one of two engineers at Esso here in Canada that had one of the first computers on his desk, because I had some rather complicated calculations that had to be done sometimes.
Hmm. Hmm.
They took weeks if you did them manually on a
Yeah.
computer, minutes. In
Yeah.
those days, probably microseconds today. But what I've seen happen in that maintenance world is when I got into Cooper's, after moving around a little bit there, the computerized maintenance management systems world was still kind of in its infancy. It had been going for a while, but the systems that were out there were purpose designed for maintenance. They weren't
Hmm.
part of some giant enterprise-wide accounting system that you find in many cases today. Um, and they were designed typically with one industry in mind. Like one that I worked with was designed around pulp and paper operations. And then you had systems like what is now IBM's Maximo. It was PSDI in those days, and I'm not sure if that's one or two incarnations before the current version. But there were systems like that were very purpose designed for maintenance, and they worked reasonably well. Um, what I've seen happen over the years, though, is that we've gone from a lot of resistance to using computers, and that was largely in the older part of the workforce, like kind of my era of person who frankly didn't really want to use computers at all,
Yeah.
and weren't really that comfortable with them. I've had to use them my whole career, so I'm maybe a bit of an exception there, but most of my cohort, if you will, were quite resistive and didn't want them. So these earlier systems really struggled to gain traction.
Mm.
And and I what I've seen over the years is as those people have started to retire, and they're pretty much all gone from the workforce today, that resistance doesn't exist anymore. And you've replaced them with a group of people who are much younger, who have grown up with computers, and today the newest ones in the workforce are what I call true digital natives. I'm surprised if they're not born with cell phones in their hands. I don't know how the
Right.
mothers handle that, but anyway,
Exactly.
the perceptions of technology and how it can be used are much different than what they were back when I got started. Um, but one thing I'm noticing with that newer workforce is that there's a trust in computers that I honestly think is misplaced.
Mm.
Somewhere along the line, and I put part of this down to the fact that the larger accounting systems have sort of grown maintenance modules as part of them, and I'll keep the names out of it. But they've added these things on to what's basically a system designed to manage transactions, and maintenance has a lot of transactions around parts and work getting done,
Sure.
hours being recorded, contractors being paid, all that stuff. So they're good at managing the transactions. Um, they do have a certain amount of workflow built into them. If they look at things like the simple work management workflow that even I have in my book, it shows 6 steps. You identify, you plan, you schedule, you assign somebody to do the work, they do it, and then you learn from that. But that suggests that everything is a one-piece flow through that process. It's not. Some steps of that are one piece, like planning. You plan one job at a time. You don't necessarily plan for a work order, but that's what most people do. But if you're saving them, you just plan for work. When the work order requires it, you can pull it out of the database. Like I used to pull them out of file cabinets once upon a time.
Right.
But a lot of planners don't know how to do that. And they're too busy sort of keeping up with the day-to-day panic. The next step in the process is scheduling. It's not a one work order by one work order task. It's actually a batch process, and people don't seem to understand that. And the computer systems that are out there are not well programmed to handle that.
Mm.
And in fact, I see a lot of people that do planning to manage their work. They go outside of the main work management system to another system just to do the scheduling, and then import those scheduling dates and times back into the main system. I don't see why that should be necessary, but it's design of the system that leads to that, and that design is from some flawed thinking. And I think I've seen enough of this now to be confident in saying this, that the programmers really don't know what they're doing in maintenance. And I don't blame them. That's not their shtick.
Hmm.
But they don't have guidance in how these processes should work and how they should integrate with each other. So you see, what I see in the computer systems is a replication of the silos that are created in most businesses. If you go back to Henry Ford's assembly line, and there's a step in every, there's a number of steps in sequence to build a car. Well,
Yeah.
businesses kind of run like that. All the departments are like steps in a process, right? And the assumption is that everything works well in each step, but that you hand off from one step to the next, and that's not really what needs to happen. There's an interaction or an integration, if you will, in computer terms, that's needed between things like maintenance planning, maintenance scheduling, spare parts inventory, inventory management, purchasing, right? And those are not integrated. And that's a big problem that's really plaguing systems, with a lot of focus on the systems, and you even use the term solutions. I don't like that term, to be quite honest with you,
Okay.
because they don't solve anything. In
Yeah.
fact, I'm kind of convinced that a lot of these systems that are out there actually cause more problems than they solve. Or certainly leave the door open for people to cause their own problems,
Right.
and don't really help them out that much. They're not solutions. Software is just a tool. It cannot think. It cannot solve a problem. But it can be a useful tool if used by someone who knows what he's doing in a process that actually makes sense. And,
Hmm.
and I find that a lot of the software that's out there isn't really programmed that well. And I mean that from a process perspective, not from the programming could be as efficient and good as it can get. But if you're programming the wrong thing, it's still not going to work. And I think
Right.
that's what's gone on. Like in maintenance, a lot of people focus on planning and scheduling. They think, okay, if I do good planning and scheduling, I'm going to get more work out of my workforce. I'll get higher productivity. And yeah, in theory, you can. But if they're doing the wrong maintenance, all that productivity doesn't do you much good. And it's the same thing with software, right? You can program it really, really, really well, but if it's not programmed to follow a process that actually works, you're in trouble. And I see that in company after company after company, right?
Mm.
And the single biggest piece of evidence for that, I would say, is that most maintainers complain about inability to get parts they need. And you got to
Mm.
wonder why, because a big chunk of that software is there to manage purchasing and parts and stores and inventory, and can calculate mins and maxes and all this stuff. And it never works. Why? You got to ask why. And it's that lack of connection between planning and forecasting of demand, the actual collection of demand. And of course, when it doesn't work, the maintainer, he's like the lab rat in an experiment. He's going to do what he bloody well likes. And when the part doesn't show up, he says, oops, I can't get it from spares. The machine's down. I got to get something. So what does he do? Goes to his planner, who's probably not planning anyway, says, can you get me whatever it is? Planner now starts the purchasing process. All right. And he'll
Hmm.
walk it through or rush it through the purchasing process, which totally bypasses inventory management,
Yeah.
spares, and warehouse. So there is absolutely no record of that consumption. And so the inventory management system now is lacking that bit of information, but everybody thinks that because it's all computerized, it's there. And yeah, the data is there, but it's not where it needs to be, or the
Hmm.
information from it isn't what it needs to be. And I think that causes a lot of problems. I tell you, there's a lot that could be done, I think, with software that's out there to fix that.
Hmm.
But it's also going to require a parallel effort on the ground among the maintainers to follow the process.
Right.
As
Yeah.
soon as you go
Exactly.
out and buy something, you mess it up.
Yeah.
And
Yeah.
I tell maintainers, I do a lot of training on my book Uptime, and I tell them, like, you're probably your number one biggest worst enemy when it comes to maintenance processes and spare parts, and it's because you go and buy stuff when it's not there. And
Yeah.
no, you shouldn't do that. You go to stores. Stores should be buying it through purchasing, and
Yeah.
let that happen.
Yeah.
And a store says, well, it's not in inventory. Well, add it.
Yeah.
You need that one, so somehow get it on the books and order it through that proper process. But if you bypass it, you take away the chance for the data to be collected in the right places, and you rob it of the ability to do its job properly.
Mm.
And I see that time and again. Needless to say, as a consultant, I don't usually get asked to go in where things are running well. There's usually a
Right.
problem, and
Yeah.
and that's one of the big problems that shows up just about everywhere. Just
Sure.
yeah.
Sure. Well, you mentioned your book Uptime,
Mhm.
Uptime Strategies for Excellence in Maintenance Management, and I understand that's been used as a textbook in some instances. So, tell
Mhm.
us a little bit about that. What was the genesis of that project, and how did that come into being?
Yeah, well, it's now in its third edition. The first
Hmm.
edition was actually written by John Campbell. He's the guy that hired me at Coopers and Lybrand. Um, he had been a mine manager earlier in his career before he got into consulting, and he had recognized the need for equipment to run reliably, and recognized that maintenance typically didn't do a great job of providing it. And so when he got into consulting, and I'm not sure quite what sparked him to do this, but he took a number of different courses from people, some of whom are still around, as consultants, and learned a lot more about how maintenance should work, and all the different pieces of it, the planning, the scheduling. He learned a little bit about computerized maintenance systems, which in those days were still kind of in their infancy. Um, KPIs, they were all the rage back in the early 90s. And all the big business books were out back then too, around lean and
Hmm.
Seven Habits and so forth. So all of that kind of influenced him. And what he wrote was a rather light book. It was not a big thing that it is today. And it was intended for managers of operations and production. It was not actually intended for maintenance people. And the idea was so that they would understand what they should expect from maintenance.
Hmm.
Um, and what we found not long after it was published, I joined his firm, and we started using it in our consulting practice. But what we found was that the people it was targeted at just never read it. They didn't bother, right?
Okay.
But who did were the maintenance managers, and they loved it. They said, "Wow, this is the first time anybody's ever told me what I should be doing," and they had no training in how to manage maintenance. There was none in those days,
Hmm.
and they rather liked it. But they did have the suggestion that, look, it really should be more detailed on how to do some of this stuff because it wasn't originally written with that intent.
Yeah.
So with that sort of feedback, John and I decided that we'd do the second edition together and co-author it. Um, Unfortunately, this is now the very late 90s, just early 2000s. John was ill. He had cancer, and he wasn't. He was well aware that he was not going to last an awful lot longer. So we talked a lot about what that second edition should look like and the kind of depth, and we were drawing on the experience we had with our clients,
Hmm.
and we decided we'd do the second edition, add in that detail and publish it. But he got too sick too quickly, and eventually he passed away. Before he passed away, he said to me, "Look, Jim, take the book, write it, make it yours. You know what we talked about. You know the direction that we had in mind. Make it yours and do that next edition." So after he passed away, his widow, Bev, she actually gave me all the research material and things that he actually used when he wrote the first edition, which was quite a little treasure trove of information, some of which I still have here in my office. Um, and I went through that, got a good understanding where John was coming from. I knew Uptime and its model of excellence very, very well at that point, and uh, started thinking about, okay, what should I change? How should I change it? Right around that same time that he passed away was when consulting from PwC went to IBM. And so there was this timing thing. IBM insisted we all sign these employment agreements, and basically, if you wrote it down, it became their property. So it didn't
Right.
matter whether you did it on your own time or somebody else's. They wanted it, so I made a very conscious decision to write nothing while I was at
Hmm.
IBM, and
Hmm.
so I basically just kept it all in my head. And then when I eventually left, because I by that time I was already kind of thinking about, it's time to look around a bit. So I just kept it all in my head, and then when I did make the leap out, that's when I started putting together that second edition. And that one, it was interesting because at first I felt kind of bad about redoing what
Right.
John had done, and I struggled with that initially, and I was just really getting frustrated that it just wasn't coming out the way I wanted it, and yet I was trying too hard to stay true to the way that John had written it originally. So I at one point just said, this ain't working, and I literally hit the delete button on about 6 chapters. Totally
Okay.
dumped them, and started over. And I took what John had said, like make it yours, to heart, and I started writing. And it only took me probably a couple of months to write it from that point on, because it started to flow out of me at that point.
Uh-huh.
And then in 2006, that second edition was actually published. There was no difficulty with the publisher; they were more than happy to have somebody pick it up at that point. And so that's how that second edition came, and it's done quite well on its own.
Hmm.
The third edition came along again a little bit later. Again, more technology changes and a little bit more experience under the belt. And I thought, okay, it's time for a third edition. So that came out in 2015.
Mm.
So it's been modified a little bit from the start. It's a lot thicker. It does get used as a textbook at the here in Canada, the Asset Management Association of Canada. It's called PMAC. It used to be Plant Engineering and Maintenance Association, but PMAC uses it in their maintenance management professional program, which, as far as I know, is the only program out there for training maintenance managers.
Mm.
In the U.S., you've got the equivalent organization is the Society of Maintenance and Reliability Professionals, SMRP, but they're a certifying body. They're not a training organization, so they don't
Right.
offer training. They just offer certifications, and here in Canada, PMAC actually does both. So it's there, and it's the textbook for their first module in that program, and gets used as a reference in the other following 7 modules. So it's done quite well there. I've taught many courses in Uptime myself. Clients want to know, how do we manage maintenance better, so I do that on site. I've actually created online courses in it as well that we sell through our training academy. And I often go to conferences where I speak. In Latin America, it's incredibly popular. I have a 2-day course in Uptime that I teach. I don't speak Spanish, or at least not
Yeah.
very, very well. So I'm teaching in English with my slides in English. The group, the students, and there's usually around 30 in the room when I do this. They're all listening with simultaneous translation going on.
Hmm.
They're usually a little bit good with English, better than they give themselves credit for. But
Hmm.
they're taking all kinds of notes and listening in Spanish, asking questions in Spanish. The translators translate English for me, and it actually, I've done it enough times now, it flows pretty easily. I have created Spanish versions of the slides for them so they can download them, and if they want to read along in Spanish, they can.
Right.
But the book, unfortunately, is still in English.
Yeah.
So
Right.
and I haven't been able to get the publisher terribly excited about translating to Spanish, which kind of surprises me, because I think it would be a bigger seller down there than it is up here,
Yeah.
if they ever did that.
Is that right? Well, I don't want to ruin it for potential readers, but can you really quickly give us maybe some primer points? What are the core
Yeah,
features of the philosophy?
yeah. Well, there's a model of excellence in there called the Uptime Pyramid of Excellence, and that comes from John's first edition. Actually, I've modified it a little bit since then. And there's 3 tiers to it. The leadership is at the bottom, the essentials are in the middle, and then at the top we've got choosing excellence. The leadership component is all about what one might expect. This is people, motivation, training, development of your workforce, how you're structured and organized to get things done. And a big part of that, which I don't think it's stated and emphasized enough in the book yet, is that motivation of people, and using their ability to change and self-motivate to actually get results, because people are good at that. They're not good at being changed, but they're good at change. and
Okay.
that's kind of something I've kind of learned that would be part of the next edition if there is a next edition. I can talk a little bit about that too. But the second level is about efficiency, like work management, materials management, basic care. Metrics, key performance indicators, and systems to manage it. So that's where the systems fall, and that's all the stuff that the maintenance managers like to focus on the most, right? Those are the things you do, and that you need every day to be working. And there are also things that often aren't working particularly well. The systems that exist are there to really automate that work management and materials management functions and the interface between them. And it's that interface that I think has problems. So that's that second tier. The top tier is about doing the right work. So in the second tier, you get efficient, right? You do things well. So if you've got a job, you can do it in the least amount of time with the best availability of spare parts. You're using planned procedures and so on to do the work. At the top tier, it's all about making sure you're doing the right work. Another mentor that I had early in my career was RCM's John Mowbray. I knew John quite well. I took his training course in 2000, actually, over in England. He used to say that, look, there's no point doing maintenance right if you're doing the wrong maintenance. And he's absolutely right. Now he and John Campbell had a little bit of an intellectual rivalry going on. I think competing books or something. But I had the good fortune of having both as mentors early in my career, and I learned a lot from both of them. And in my opinion, you need both. You need that discipline to work efficiently, and you need those processes. They need to be integrated properly. That all has to be in place. You have to measure what you're doing. You have to know where you're going with it. You have to have some strategic direction, even though it's not, everybody knows that you just keep stuff running. But for what goal, right? That needs to fit the company's objectives as well. And as maintainers, we often forget that. But the John Mowbray piece about doing the right work is where that top level of the pyramid comes from. So it uses things like reliability centered maintenance, root cause analysis when things go wrong. There's also an element of it that I call EBAM, or evidence-based asset management, which I would actually modify if I were to do another edition of the book. It was quite heavily influenced by my relationships with the University of Toronto's Center for Maintenance Optimization and Reliability Engineering. And they did an awful lot of work with very statistical problems to be solved. And I've worked on several projects with them, learned a lot, but the math part of it is pretty scary for most people. Even good engineers are a little bit intimidated by the level of math that some of that required. And then indeed, they had PhDs and master's degrees of engineers working on these problems. But they did get some really good solutions, and it kind of bridged that gap between maintenance and asset management, because there's, some people think asset management is maintenance, but it's not. Maintenance is a piece of asset management, and there's a lot of work that's done in maintenance that could lead to the collection of data that is actually good for improving reliability and enhancing decisions in asset management, but that data typically isn't collected very well. And part of that is the systems again. The thing I would change about it is that leap into more modern technology, particularly with artificial intelligence, and I've been getting involved with that just this past year, and finding it's got huge potential. So that's it. You got the leadership, the essentials, the things you got to do, and then there's the choosing excellence, those things that are all about efficiency. So you got the effectiveness and you got the efficiency pieces together, and that's not going to work if you don't have good sound leadership and an understanding of how it all fits together. It's only 10 elements in the model. They work together. They're what I call codependent, if you will, or interdependent on each other. You can't just pick one and improve it and expect it. I'm going to save a bunch of money. You got to look at the whole thing quite holistically for it to really work.
Fantastic. Yeah, well, you mentioned AI, so I understand you're also the co-founder of a AI job planner. Could you tell us a little bit about that? I'm afraid I'm a little ignorant here.
Well, it's an interesting little project. About a year ago, maybe it was, I was asked if I could do a talk on an online conference about AI in maintenance. And I kind of scratched my head a little bit and thought, well, there isn't any. This is going to be a short talk. But I said, look, let me dig into it and see like what is out there and what could be done. And what I found was there isn't much being done at the moment. Or at that time, we're now a little over a year later, and that's changed a bit. Um, but I thought, well, what could it do? And I thought, well, there are a lot of things in maintenance that require kind of repetitive thought processes. That the results aren't always the same, but the thinking process uh, could be. And one that I picked on was planning, and the reason was that most planning that I see is done rather poorly. In fact, a lot of planners just schedule work and call it a plan, and it's not. But that's what they think. So in order to enhance planning, I thought, well, how can we do this? And I literally went on Chat GPT and I gave it a written instruction. I want a job plan I think it was change a motor. No, align a motor and a pump in a horizontal pump and motor in a chemical process plant. That's all I
Hmm.
asked it, and it gave me a one-page long detailed plan, which was actually quite good.
Okay.
I was rather surprised by it. It had estimates of labor and time required and parts that I might need. It wasn't perfect. It had flaws. Like after you aligned the motor to the pump, it said now align the pump to the motor. And I went, well, why? You've already got them aligned.
Yeah.
So there were some things like that were not quite right about it. But I thought this has potential, and it's in a format largely text based that somebody who knew what they were doing could probably pick it up and use it. Now, it didn't have a lot of specifics about what kind of pump, what kind of coupling, what kind of alignment tools.
Yeah.
It didn't have tolerances and things like that. So it missed some details, which I expected. I didn't give it a lot of detail to start with. It had an extra step that really wasn't needed at all. But it was way better than most plans that I've seen planners create.
Right.
All right. So that gave me some hope that there might be some potential here, and I talked about that in that particular online conference, and people got quite interested in it. I also talked about it with a couple of colleagues of mine, and one knew a bit more about AI than I did, and he said, well, we could use some rags and draw in equipment specific information. Don't ask me what a rag is. I have no idea. Programmers understand it, but we could use those to pull in equipment specific information to add some of that detail to those plans. And I thought, well, that's a really neat start. And then with another colleague who works in a company that does analytics and uses some AI tools in the analytics process, we got the three of us together and sat down one day and we said, look, why don't we create this tool for planning? And we had the development guys in the analytics company. We had the knowledge of what AI could be doing for us from the one fella, and then just had that basic idea from me. And we went ahead, and 3 months later, we had a working tool. It actually does a really good job. Not perfect every time, and we emphasize with people that are going to use it that it's producing draft plans. We're not producing a final plan that you can use.
Right.
It is intended as a productivity tool. It is not intended to replace planners. Um, I think that's a fear that people have of it is that,
Hmm.
oh, this is going to take my job. Well, no, it's not going to take your job, but a planner that's using it might.
Yeah.
That's kind of the way I look at it. It's just like the question's been asked me about, was AI going to replace consultants? And I think, no. Um, a consultant that uses AI can certainly be more productive. And yes, that consultant might replace someone who's not using it, but will it ever replace that combination of experience and knowledge that you get in the field? That there's not a chance. The AI routines, they do some pretty amazing stuff. They're pretty surprising and
Hmm.
pretty good, but they're not as perfect as a lot of people might think they are. I think there's a lot of misinformation about them out there, and a lot of
Yeah.
fear. A lot of fear
Yeah.
that's, I think, quite unprecedented, but you don't really realize that until you start to work with it.
Yeah, fair enough. Good. Well, you're going to be a speaker at Dynaway Connect conference this coming April, and we're
Yes.
excited to have you, James. So I understand your session is going to be entitled Operational Readiness, Setting Yourself Up for Success. Give us a hint maybe of what you're going to have packed in there for us.
Well, the hint for anybody that's ex-military is integrated logistics support, which will probably draw a blank stare from most people. But back when I worked on those defense projects, the shipbuilding project, the helicopter project, landing systems, we used this thing called integrated logistics support, which took at its front end, a very detailed look at what work was going to be required to support a system once it's put in the field. So the way we start off is literally do reliability-centered maintenance on the systems. And from that, you get a whole bunch of tasks, maintenance tasks that need to be done, maintenance tasks that will be done to repair things when you've decided to let it run to failure. There will be some changes to maybe operating procedures, or you will recognize in doing the analysis that maybe you need operating procedures where there aren't any. If you take each of those things and now look at it and say, what do I need to do that? So what do I need to do that repair? Well, I need these parts in this quantity. I need these materials in these. I need this trade, and I need 2 of them. I need 1 electrician, and so on. So you actually do a planning job after that, and then from that you now put all those requirements that the plan defines into place. Okay, so I've defined what parts I'm going to need. So which parts do I need to have? I need to make some decisions. Do I keep them in stores, or do I just buy them as I need them? So there's some logistic decision making that has to be done in follow-up from that with say various procedures and tasks that are going to be performed. There's a need to look at the training that might be required for the people that are going to actually do the work. Like so when I did this on the naval ships, for example, Canadian Navy was moving from believe it or not, vacuum tube technology to solid state, and that was a big leap. Their electronics technicians did not know much about solid state tech, so there was a lot of electronics training that had to be done. Right. The older ships in the Canadian Navy had guns. The new ones were going to have missiles. A little bit of learning needed there. You don't maintain bullets, but you do maintain missiles. And a lot of people, what, you maintain missiles? Yeah, they're not bullets.
You're darn right you do. Yeah,
they've got guidance systems and communication systems and all kinds of stuff that you don't have in a dumb bullet. So, there was a whole, like, we needed a maintenance facility for missiles. We needed a maintenance facility for for electronics that wasn't there before. We needed to train people on how to operate an integrated machinery control system. Like when I was a sailor, it was steam turbine-driven ships with boilers. You were literally down there turning valves and turning things on and draining tanks. It was a lot of very manual work in those steam systems. The modern systems with gas turbine engines are quite different, and a lot more electric driven than steam turbine driven. So the way you actually ran it and maintained it was quite different, and we needed to train people on how to do that. That all came from looking in detail at the new systems and equipment and deciding what is it that's needed to run those. So that's what that talk is all about, is that process of putting all that support in place. And it sounds like a lot of work, and it is a fair amount of work, but when you look at it relative to a capital project, it's actually fairly small. When we did it for that ship, it was probably 2 to 3% of the capital cost of the ships were spent on it. It's not a huge amount. These days, with the computerized tools that we have, it'd probably be a little bit less effort. We've got methods for doing things like RCM that are far more elegant today than they were back then. So we've got smarter ways of working now that can be applied, because it wouldn't be for military. It's my version of it is for industry. It's a lot less gold plated,
right?
And much more focused on the result than it is on the method and the process. So. I believe that's something that industry is really missing the boat on. I've been involved in a number of projects in industry that, take a long time to get started, to run smoothly. when they're handed over from, say, the engineering and construction to operations, a lot of times the construction isn't even finished. The contractor by that point in time has made, really blotted his copybook, so to speak, and they're pretty much thrown off site, and it's over to maintenance. Hey guys, make it work. Here now you got people that don't know anything about those new systems taking it over and learning as they go. They might have commissioning spares, pretty much all of which were designed for the PM programs that the manufacturers recommended. And if you've ever done any RCM work, you'll know that those are usually not the right things to do. So you've got the wrong spares to begin with, and you're going to run into all these problems when things start to break down on startup, and they will, because you've not trained people properly how to operate it. And you're going to be chasing your tail, and you'll never stop. You just keep going for it. It takes a long time to get things to stabilize. If you were designing a new, say, aircraft today now, and the aircraft industry does get this right, by the way, but you're comfortable getting on an airplane that's new. You know that they've got it all figured out. And I just ask a lot of my customers, like, would you actually fly in an airplane if it was maintained by your maintainers? And the maintainers sit there and say, not a chance. Right.
Right.
Wow. Their idea of improving reliability is to use root cause analysis methods, and they're great. There's nothing wrong. They're very precise because they target exactly what went wrong. But the key to keep in mind is that they target what went wrong, not what could go wrong.
Right.
And they're doing it reactively. And I ask, well, would you fly on an airplane if you knew they were developing the maintenance program using root cause methods? And again, that same horrified, not a chance, response. So, there is a way to do it right. It's done where there's a very keen interest in safety and operability right from the start. Most industrial systems, although the companies would love that they worked really well, don't actually invest in making sure that they do. And I think for that, little incremental investment up front, you'll get a much more rapid ramp up, much more smooth operation. You really are setting yourself up for long-term reliable success, and contrast that with what you see in most organizations today, and it's a massive improvement. That 2 or 3% that you just spent is probably going to pay for itself well within the first year, would be my estimate, based on some of the calculations I've done with real projects that I've looked at in the past. And I felt like if they'd done it, man, they'd be way ahead. And today I work with companies where they've been in operation for 20, 30, in one case recently 60 years, and they've never got it right. Like I said earlier, if they're doing well, they don't need me, but they call me in because they're not. And you can see that some of this goes way, way, way back. And it's all from not being prepared at the very start. And it's so easy to do. It's all stuff that we know how to do. It'll save you a lot of effort, a lot of time, a lot of money, a lot of lost production. It's just huge benefit from getting it right if you do.
Wow. Wealth of knowledge, James. I'm excited about Connect in the spring, and excited to hear your talk. So I'm looking forward to that.
Thank you.
So I think that about does it. I want to thank everyone for listening today. Please, whatever platform you're listening on, like, subscribe, give us a comment. Would love to hear from you. And that kind of wraps it up for another edition of Dynaway Dialogues. Thank you, James. Look forward to seeing you in the spring.
Terrific, Jesse. Thank you, and I look forward to seeing you again, too.
All right.
Take care.
Talk to you soon.
Right. Bye for now.